of Engineers is building the biggest surge barrier in the world. Shaw Group is constructing the barrier around a series of huge reinforced hollow concrete piles that are driven almost 130 feet into the lake bed. Thinner piles are then sunk to fill in the gaps. This concrete wall is then to be supported by a series of enormous steel pipes, each one 248 feet long. These towering steel rods will be planted in the lake bed at a 45-degree angle behind the barrier. Next, the piles are filled with more concrete and steel reinforcing bars, and then a cap and parapet wall is added to hold the supports in place and raise the height of the barrier to 26 feet above sea level. In all, over 4,400 gigantic piles will have to be sunk to complete this mammoth structure. Work began in May 2009. Driving the main piles into place requires a special piece of equipment. A massive piston pushes the piles into the ground. When the piston comes down, it compresses a mixture of fuel and air in the chamber above the concrete pile. When the pressure reaches a certain point, the fuel explodes, pushing the pile down, and the piston rises, releasing the exhaust gases. With each push, the pile is driven another inch into the lake bed. In 5.5 months, 1,271 piles are hammered into place. The next challenge, to plant the huge supporting metal spikes behind the barrier. The spikes are ferried to the barrier on barges. Each of these steel poles is over 200 feet long, almost 3 feet across, and weighs 100 tons. One at a time, the steel pipes are lifted carefully onto a long frame. The frame is attached to the concrete barrier below at an angle of 45 degrees. Once the spike is safely on the frame, it is slowly lowered into the water. When it reaches the lake bed, a massive hydraulically driven 35,000-pound hammer gets to work, slamming down with a force of 88,000 foot-pounds. The entire barrier shakes as it forces the giant pile into the ground.
Science Channel will show you how the universe's most powerful events, asteroid impacts.
With the two sections joined, the final few feet of hammering can begin. Once one steel pipe is in, the frame above then has to be unbolted and moved along the barrier ready for the next one. Back on dry land, the steel work that will provide the reinforced skeleton is arriving. The Army is working fast. 100 tons of this steel is arriving each day. The steel frame is then pulled, pushed, weaved, and tied into place. By the time it's finished, the barrier will contain enough steel to build 8 Eiffel Towers. The finished sections are carried by a shuttle to the water and then loaded onto a barge. And then, section by section, concrete is poured over it. With the steel pipes in place, it's time for the reinforced concrete cap, which will hold everything together. It comes in chunks, 106 tons at a time. Slowly, carefully, each section is lifted into position. The men push and pull the huge concrete cap before it is gently lowered into place. And with the heavy lifting done, the protruding steelwork is tied and enclosed with more concrete, ready mixed and delivered from a waiting barge. When Shaw Group completes it, This extraordinary fortification will present a formidable 26-foot-high barrier to the advancing sea.
We're constructing a wall here which we know is pretty robust. I mean, several hundred years from now, this structure will still be here because nobody's going to take it. It's not coming out anytime soon. So the reality is this will provide viable surge protection for the city of New Orleans for a long time to come.
But this is only the first line of the city's defenses. About half of New Orleans sits below sea level. The canals are higher than much of the city, and the city has more canals than Venice. They're used for drainage, transporting rainwater away from the city into the sea. But when Katrina struck, the sea rushed in, undermining these canal walls. Some collapsed, with disastrous results.
So we're going to start, where are we going to start again?
Sir, right around...
So the Corps has to find a way to keep the sea out, while still allowing water to drain away. The solution is to build a floodgate flanked by gigantic pipes. When the gate shuts, the pumps are turned on and the canal drains through these pipes. Work on the floodgate began in January 2006, and just 5 months later, the floodgate and pump station were operational. Right on time to defend the city from the new hurricane season. It looks like a small hydroelectric dam flanked by massive black tubes. The tubes are connected to a series of pumps with a combined thrust of 37,500 horsepower. Lives depend on these pumps working properly. Every 2 weeks, the pumps are tested to make sure they're ready if another hurricane hit.
3 pumps go into one header, and we're looking for a discharge reading on this meter.
Together, the pumps shift 500,000 cubic feet of water a minute.
Like that? Pump. Okay, see the CFS is starting to come up now.
The combined planning, on-site personnel, and $14 billion worth of pumps, floodgates, and barriers provide the city with multiple layers of protection. As the sun sets on another day, the next shift arrives to continue through the night building the vital surge barrier. There is no time to be lost. People's lives are at risk, and there's a great American city to be saved.